Alaikum and good day everyone. Today I am going to explain about my video assignment, which is the second assignment for atomic physics. I am going to explain about three main topics, which are blackbody radiation, photoelectric effect, and Compton effect. The first part of the explanation will be blackbody radiation. First of all, blackbody is an object that can absorb and emit all wavelength with equal efficiency. It doesn't matter what type of material is used to build that object. Meanwhile, blackbody radiation is a thermal electromagnetic ray (EMR) emitted by a black body in thermodynamics with its surrounding, which means that the heat transfer of the black body with its surrounding. Because of its efficiency in emitting all wavelength with equal efficiency, the blackbody radiation can be used to study relationship between the properties of intensity and wavelength at fixed temperature. For example, in a dark room, at room temperature, the object inside the blackbody object inside the room will appear dark. This is because that the highest intensity at room temperature is infrared band. However, in higher temperature, a little higher than the room temperature, the object, a blackbody object, will appear in the visible wavelength, which can be the red band of visible wavelength, because at that point, at that higher temperature, the red band of visible wavelength is the highest intensity, so the blackbody object appear red dark. To make it easier to understand, based on this graph, each different temperature will have different peak intensity. The 6000 Kelvin have visible wavelength has its highest peak. Meanwhile, the lower temperature have its highest or peak intensity shifted to the right. Because of that, it can be concluded that specific frequency will have specific energy level. Next, photoelectric effect. This is the basic experiment of photoelectric effect, which is an incident light is emitted into an emitter which have an electron. So the emitter is actually a metal rod that contain an electron. After the incident light hit the emitter, it will release an electron or photoelectron into the collector, because the incident light transfer its energy into the electron. It break the binding energy and release the electron. So photoelectric is an emission of electrons from a material when hit by EMR. But in classical physics, electromagnetic ray, which is AMR, is a continuous wave. Based on this classical physics theory, when an incident light is hitting an object, it can build up energy over time because of its continuous wave nature. So faster build up when high intensity, which means the higher brightness will transfer more energy faster. But the result of the photoelectric effect is continuous beam over time. There is no photoelectron. Higher intensity, no photoelectron. But by increasing the frequency, there is a release of photoelectron. So let's say initially the frequency is in red band. They use higher intensity of red color, but no photoelectron is released. And when they still continuous beam, there is still no photoelectron. But when they increase the frequency into higher frequency, let's say orange, the photoelectron is released, even the lowest intensity. So to make it more easier, the explanation before, when the potassium is require 2 electron volt to eject an electron, and when they use only red light, no matter the intensity or the duration, no electron is released. But when they increase the frequency into green wavelength, there is a release of electron. But even when they change the intensity or the duration, the volume of electron ejected per time is still the same. It is only increase when they increase the frequency again into blue wavelength or violet. So conclusion, photon travel in discrete wave packets and not continuous. This conclusion was made by Einstein. So from this experiment, it can be concluded that electron energy is quantized. It is not in random or floating number, but in a quantized volume. Finally, Compton effect. Compton effect is when a wave collides with an electron. So basically, particles such as electron will scatter when it collides with other particles to preserve its energy and momentum. However, interestingly, when the incident X-ray photon hit the electron at rest, the electron is scattered as expected, but even the X-ray is scattered with reduced wavelength. The X-ray was scattered, and this showed that the X-ray, which is wave, has and can exhibit a particle's properties. And from this experiment, it proved that a particle or lights can have duality, which means that an X-ray or a wavelength can exhibit particles nature, while an electron can exhibit wavelength nature. And because of this Compton effect, it's further approved the photon theory by Einstein. And that is all from me. Thank you.